All right, so remember, Thursday is the last day to hand in any missing assignments. If you need any, you need to let me know ASAP so I can get them printed off for you. They're also posted on Google Classroom, all the assignments for all the chapters, so you can print them off from home if you want. So last day is Thursday. Also, that is the day of your final exam here in this room, Thursday afternoon at 1 o'clock. So that means then that on the day next week when the Block 2 exams are scheduled for the finals, so that is next Wednesday, January 25th, that means you don't have to come to school that day because you won't have to write an exam next Wednesday. So again, our exam is Thursday, 1 o'clock. I sent out an email this morning to remind you and your parents, and I'll probably send another one out Wednesday or so to remind you, but make sure you're here at 1 o'clock on Thursday to write your exam, and that's also the last day to hand in any missed assignments. Okay, so the next chapter was dealing with slope. Basically, the slope of a line tells you how steep it is. That's really what it is. It's a number. When the slope is positive, that means that the line rises as you go left to right. When the slope is negative, it falls as you go left to right. Ethan, if you have the final exam review notes, that's it there if you don't have it. Okay, so when you find the slope, it's a number. It tells you how steep the line is. When it's positive, the line rises as you go left to right. When it's negative, it falls as you go left to right. So we saw that slope was defined as the change in y over change in x, or the rise over the run. This will be given to you on the formula sheet. You don't have to memorize it, but you got to know how to use it. Slope is rise over run. So the very first question asks us to find the slope of a ramp with a rise of 3 feet and a run of 9 feet. So it's just as simple as dividing the rise by the run. 3 divided by 9, which could be reduced to 1 over 3, or if you get it as a decimal, 0.3 repeating. Slope is that simple. Rise divided by run. If you're given the rise and the run, you just divide them. In the case of the second one, we want to find the slope of this line. Well, we can get the slope by counting the rise and the run. You just need to know 2 points on that line. And then you can count how far up you have to go. That'll be the rise. How far to the right you have to go. That'll be the run. This line has a positive slope because the line is rising as you go left to right. And from positive 1 up to positive 5, you're going to rise 1, 2, 3, 4 units. So again, slope. And we also saw that the letter M is often used to represent slope. So again, you're going from 1 up to 5, which is a rise of 4 units. And then you're running from 0 to 6. So that's a run of 6 units. That fraction reduces to 2 over 3. You can divide top and bottom by 2, and that's the slope of that line segment. If you wrote it as a decimal, you'd have to round it because that's 0.6 repeating. If you go to 2 divided by 3, that's 0.6 repeating. So we would say approximately 0.66 repeating. But again, slope is a number. It tells you how steep the line is. Example 3 says a logging road rises 194 meters for a horizontal distance of 2,216 meters. What is the percent grade of the road to the nearest tenth of a degree? Well, again, slope is rise over run. So this is where we would start this. The rise is 194. The horizontal distance will be the run. That's 2,216 meters. So that's where we start this. If we go to our calculator and we go 194 divided by 2216, That is a decimal, 0.0875 approximately. So that is the slope. It's always also the grade as a decimal. To get it as a percent, which we're asked to do, you got to multiply by 100. And so we'll take our calculator and multiply that by 100. And that is the grade as a percent. We're asked to round it to the nearest tenth of a degree, which would be 8.8. The digit in the tenth place is the 7. To the right of that is a 5, which means the 7 has to go up. So it's approximately 8.8%. So there's the answer. Slope is also known as the rate of change. Example 4 says a 60-liter tank fills in 10 minutes. What is the rate of change in milliliters per second? Okay, so we have to do a little bit of conversion for this. You're going to get 60 liters in 10 minutes. So that would be the rate of change in liters per minute. But we actually want milliliters per second. So 60 liters, you have to remember that there's 1,000 milliliters in a liter. So if you multiply that by 1,000, that'll be 60,000 milliliters over, and there are 60 seconds in a minute. So if you multiply the 10 by 60, you'll get 600 seconds. Sorry, 6,000. Nope, was right the first time. 10 times 60 is 600. So it's 6,000 milliliters per 600 seconds, and if we divide those, we'll get our answer. 60,000 divided by 600 is 1,000 milliliters per second. And so there's the answer for the rate of change in milliliters per second. Number 5 says an underground parking ramp is designed to rise 8 meters. We're told it has a slope of 0.2. Find the horizontal distance, which is the run. So again, we know that m, the slope, is rise over run. In this case, we're told the slope is 0.2. The rise is 8 meters. We want to find the run. We make both sides a fraction, and then we cross multiply. 0.2 times x will equal 1 times 8. And then we would divide both sides by 0.2 to get x by itself. So 8 divided by 0.2 is exactly 40. And that would be in meters because that is the unit on the rise. So we did questions like this where you're given the slope in either the rise or the run, and you're asked to find the missing dimension. Example 6 says that the graph represents a side view of part of a roller coaster. Determine the rate of change in height for each segment of the graph and explain the meaning of each rate of change. So, the first section of the graph is section AB. So m, the slope of AB. And remember, it's always rise over run. So to go from A to B, it's rising 12 meters and it's running 8 meters. So this will be 12 meters over 8 meters. And that's the slope of 1.5. So that's our first section. The second section is BC. This part doesn't rise at all. It's perfectly flat. It does run between 8 and 12 meters, so that's a distance of 4 meters. But the fact that the top is 0 means that the slope is 0. And so this means that the graph is not rising or running, but the height is staying the same. So we'll say the height stays the same here. So the next section would be CD. So this part is a negative slope. It rises from 12 down to 6. So that's a rise of negative 6. From 12 down to 6, it's going to go down negative 6 units or meters. And the run goes from 12 meters to 20 meters. So that's a run of 8 units. So that would reduce to negative 3 over 4, or negative 0.75. So in this case, the roller coaster is falling. It's going lower. Whereas in the very first section, where it was positive 1.5, in this case, the roller coaster was rising. It was going higher. And the last section is DE. So M, the slope of DE. Again, in this section, the roller coaster is not rising or falling. The height is staying the same. So the rise is 0 and the run is 4 units. Again, this means the height is staying the same. It's not rising or falling. The height is staying the same. It's a flat section of the roller coaster. Which part is steepest? Well, the first part, because that has the highest slope of 1.5. So section AB. Because the slope is the greatest. 1.5, that's the highest number. Okay, so those are the main parts of slope that you need to know. I will hand out the assignment, then I'll post the solutions on Google Classroom so you can check your answers. Remember, once again, Thursday is the last day to hand in any missed assignments. That's also the day of our final exam at 1 o'clock. So make sure you're here for that. I've posted all the assignments on Google Classroom in case you want to print some off from home. But if you give me a list of what you need, I can also get them together for you. But you need to do that. Get me that list of what you need. So again, today